In this presentation, we'll cover the topic of social media analysis using natural language processing and information retrieval techniques. As the topic suggests, we'll be going over social media analytics and how the process of gathering data is and how we analyze the data from social networks such as Facebook, Instagram, LinkedIn, and Twitter, which then can be used by marketers to track online conversations about products and companies. Once again, we'll be discussing how we can do that using information retrieval techniques and natural language processing techniques. The team consists of myself, Mohammed Ahmed, and Clark Soniano. I will be discussing the overview of the method discussed in the presentation, as well as the goals, requirements, constraints, the design approach, the method to extract data from the social media websites, and I'll be discussing in depth the algorithm that can be used to find trends. Clara Sanviana will be discussing the pre-processing, sentiment, and abuse discovery model. So let's go to the next slide. Now let's discuss the goals of this presentation. There are two goals from this presentation. One, we have a natural language processing technique that performs sentiment analysis. Now, using the sentiment analysis, we can label and review thousands of social media posts and find out which products have positive sentiment or which products have negative sentiment. That's one application. However, using our same sentiment analysis algorithm, we can predict over sentiment trends, but also abusive posts that are making personal attacks or inciting violence or using abusive language or in general make the internet a worse place for others. So using our sentiment analysis algorithm, we will be able to detect those posts and those users, and they can be removed. So now let's discuss the project requirements and constraints. The methodologies that we are presenting in this presentation are not a demo, which means they can be implemented into a full software product that does sentiment analysis on social media posts or data. So using our methodologies that we present in this presentation, one can determine sentiment, identify abuse, or discover trends. So regardless of the source of data, whether it be Facebook, Twitter, LinkedIn, TikTok, YouTube, one could find out the sentiment and the trends from that data. And this is possible because we describe how to get the data and how to treat the data. Let's discuss the design approach that we present in this presentation. First, there can be multiple design approaches to perform the same task. However, we'll take a more general approach. So our pipeline for the natural language processing is composed of three main components. First, we have the data gathering unit. As the name suggests, it simply gathers the data from whatever social media we want to gather it from and stores it in our storage layer or storage unit. And the storage unit can be either in the clouds, such as AWS for example, or our private hardware. The third component is the analysis component. This is the main component that does the heavy lifting, meaning that it gets the data from the storage layer and then it's going to perform pre-processing, it's going to find sentiment, trends, and abusive models posed from that data. Lastly, this is an optional component, it's the interface. So if we want someone else to have access to the output, then we can have a web application or have command line interface through which you can have input data and see the outputs. So this allows for sharing of the results with others through a web application or just for ourselves. Here we have a visual for our design approach that we discussed earlier. So on the left hand side, we have the social media component. So the data can be gathered from any social media platform using our crawler component, and with the use of the crawler component, what we can do is also pre-process the data so that some of the sensitive information or the information that we don't need won't be saved into our storage unit. And when we need to use the data from our storage unit for data analysis or machine learning model, we can transform that data to so that the machine learning model or the data analysis component has easier time dealing with the information and the way that information is presented to it. Hence, we get better results, which then can be stored into our storage unit. And then for further use, we can call the results from our data analysis to any interface we like. Now let's discuss the data gathering component. As we mentioned earlier, that our methodology is not affected by the choice of social media, meaning that whether it's Twitter, Instagram, Facebook, or TikTok, or any other platform, social media platform for that matter, we still will be able to extract the data using our methodology. Now, the methodology for data gathering has one part, essentially, and that is to use the proper APIs to create a crawler which is going to extract the data from the social media of your choice and pre-process it however you prefer. The key is knowing which APIs to use for which social media. So for Twitter, for example, you can use TweetPy, the Twitter API, or the other web scrapers out there. So for this part, we are assuming that the developer has enough knowledge to accomplish this.
Hello everyone, my name is Cleverson Viana and I'm going to talk about our subsystem data preprocessing. Data cleaning is considered a foundational element of basic data science. Data is the most valuable thing for analytics and machine learning. When it's coming to the real-world data, it's possible that the data might contain incomplete, inconsistent, or missing values. If the data is corrupted, then it might provide inaccurate results. What is data cleaning? Data cleaning means the process of identifying the incorrect, incomplete, inaccurate, irrelevant, or missing parts of the data, and then modifying, replacing, or deleting them according to our needs. First of all, we need to pull the data from any source, such as any database or live feed from any website from the internet. At this time, data can be very noisy and contain misspelled words, abbreviations, shorthand words, and emojis. We can use VADER library to provide a sentimental analysis on the emojis. Spell checking can be done using some Python library such as GingerIT or PY spell checkers. Also, we have to remove hashtag symbols and links to the websites. After all data cleaning, we can create a new data frame with the data ready to be analyzed. Subsystem sentiment analysis. Sentiment analysis is a powerful marketing tool that enables product managers to understand customers' emotions in their marketing campaigns. It is an important factor when it's coming to product and brand recognition, customer loyalty, customer satisfaction, advertising and promotion success, and product acceptance. Sentiment analysis or opinion mining uses NLP to determine whether data is positive, negative, or neutral. Use off-the-shelf solution that incorporates NLTK's core data structure and functionality such as NLTK libraries from Python. We can use VADER or TextBlob for off-the-shelf sentiment. TextBlob returns polarity and subjectivity of a sentence. Polarity lies between -1 and 1, when -1 defines a negative sentiment and 1 defines a positive sentiment. Negation words reverse the polarity. TextBlob has semantic labels that helps with fine-grained analysis. For example, emotions, exclamation marks, and emojis. Subjectivity quantifies the amount of personal opinion and factual information contained in the text. The high subjectivity means that the text contains personal opinion rather than factual information. And subjectivity lies between 0 and 1. Sentimental analysis relies on the pre-processing step. So that means we need to have the data cleaned first before you apply the sentimental analysis using any Python library. Subsystem abuse discovery. Pre-built abuse discovery algorithms are hard to find. To obtain high ranking, spammers need to collect significantly more positive responses than negative ones. For example, review and reviewer ranks on Amazon are based primarily on the number of helpful votes received. Since multiple votes from the same user on one review are often counted as one vote, spammers need to boost their ranks by gathering positive votes from different users. One possible way to do this is for spammers to collaborate to vote high. We must build our own using publicly available pre-labeled datasets. So the first step is to numericize every instance into words as a numerical data structure, as no TD, IDF, bag words, endgrams, etc. After that, input data and then train various machine learning algorithms such as NN, naive Bayes, random forest, etc. Lastly, we can compare the performance of the average of the area under the curve and choose the best algorithm to put for production. So after that, we can analyze every instance and pipeline and list to the front-end component for human review. So the basic idea is having like a back-end working and doing our machine learning process and cleaning process and training process and then fetching the results to a front end that someone can review them and give the final answer. So we can currently see like abusive posts as outliers in the sentiment score plotting the graph here.
Hello everyone, my name is Mohammed Ahmed and I'll be discussing the trend discovery subsystem. The trend discovery subsystem essentially is the component that will take the data from the storage component, whether it's from social media websites, blogs, or reviews, and then try to find trends from that data and then present it to the end user by sending it to the web application component. Now, there's two parts to the trend discovery component. One is the pre-processing that it'll perform on the text, then finding the trend from that normalized text. So let's continue. So first, the trend discovery subsystem takes the original text and performs tokenization and case conversion, which means that both the sentences and the words will be tokenized and all the uppercase letters will be changed to lowercase, hence removing variance. Next, stops words and conjunction words will be removed. Once again, removing those stop words and small words that are common will essentially remove words that don't actually add up to the trends. Next, we have part of speech tagger. So for all the words, we'll be tagging the corresponding part of speech label. Next, we remove verbs. Once again, those are just words that don't actually say anything about the trends. Lastly, we have stemming and lemmatization. Both of these steps are to reduce the variance between the words and to reduce the tense of the words. Lastly, we will use association rules to find the trends between those pack of words that we just obtained. Now let's discuss the significance of performing the pre-processing steps that we discussed in the previous slide. So doing processes such as stop words and verbs removal, converting the uppercase to lowercase are ways to remove unnecessary words and to reduce ambiguity between the words. Lastly, performing stemming and lemmatization also reduces the variations between all the words. Hence, our mining objective is complete because now we will have a bag of words where there's very little variance. Now, when we're trying to find trends, there's a couple of challenges. One of the big challenges is that we don't have a ready-made off-the-shelf Python library or libraries that allow us to just give them the raw data and they give us the trends. So some challenges can be minimized, whereas others can't. One of the other challenges that we have to deal with is that we want to find a model that gives least number of false positives and false negatives. Another challenge is that ensuring our pre-processing steps clears out unnecessary words so that when you're trying to find the trend, it doesn't take too long. So our trends are as recent and as concurrent as possible. The last challenge is that we need to ensure the pre-processing processes and the association rules are working and are effective as intended, meaning that they don't have biases or come up with trends that are not actually representative of the data, rather just outliers. Lastly, let's look at a couple of real-life applications that our project can perform. Using information about products and services which receive positive sentiment. What we mean by this is that when we have the data and we see that from the posts or social media or blogs that certain product services have positive sentiment in the public, this means that those products will be high in demand. So we can have our influencers promote those products and services. Hence, those products and services will receive a good market in that period of time. Next, we have, let's say, public issues, and there is a lot of discussion going on social media in terms of public sentiment towards being pro or against that issue, and we can have our candidate support the larger volume of people that whether support that issue or are against that issue. So we can have our candidate reach out to those major populations. Lastly, as AI engineers, we need to ensure that our AI systems are used ethically, are fair to the public, and do not contain biases. Because if we cannot ensure that, then they're not reliable to the public, nor are those systems will be fully trusted by our public. Thank you. Lastly, we have the references on this page, and thank you for your time.